In the last tutorial in section 7.2, we are going to summarize all the section ideas where the objective is to find the gradient of the function f of x equal x to the power n at any point. Back to the book, page 119, we have an explanation, but we are going to try to rearrange it so we can understand the idea or the ideas in a better way. We can say, in general, it can be shown that if f of x equal x to the power n, where n is any real number, then f prime of x is equal to n multiplied by x to the power n minus 1. Then whenever we have f of x equal x to the power n, its derivation f prime of x is n, or the power multiplied by x to the power n minus 1. We reduce the power by minus 1 and multiply all the expression by n. This is the general formula that we are going to use to find the derivation for any f of x. Previously, we found that f of x equal x squared, then the derivation form, the derived form f prime of x is 2x, where 2x is n multiplied by x and x to the power 2 minus 1 is 1. 2x. We approved this before. For f of x equal x cubed, then we are going to multiply it by n, that is 3, and reduce from x or the power 1. 3 minus 1 is 2. 3x squared. Then for f of x equal x to the power minus 1 or 1 over x, it gives us the n multiplied by all the expression, which is minus 1 multiplied by x to the power minus 1, and we reduce also minus 1. The minus 1 is going to be minus 2. Notice the pattern in these results is the same each time, and the formula is applicable. Then also, you know that the gradient of the straight line y equal x is 1. We know that. We did this example previously. For the straight line y equal x, the gradient is 1. And when we have the line or the straight line equal to constant 1, then its gradient equal to 0. Let's try to apply the formula for these two examples. For f of x equal x to the power 1, then we said the derived form is 1 or n multiplied by x to the power n minus 1, that is going to be x power 1, or 0, that is equal 1 to 1. And for f of x equal to 1, we know already x equal to 1 is x power 0. Then 0 multiplied by x to the power 0 minus 1 is 0. And here we prove that for y equal x, the gradient equal to 1, and for y equal to 1, the gradient is 0. And thus the formula can be used whenever we want to find the derived form for any expression or f of x.